Okay, hello students. So as promised in this video, what we'd like to do then is look a little more carefully at the multi-channel analyzer and what it does with these channels versus counts. We want to just double and triple make sure you understand exactly what it's doing. And just remember that the input to the multi-channel analyzer is coming from this little black box here. So basically it's a voltage between 0 and 10 volts is what's going to come in. And this is sort of what we have to wonder about. Okay, so what I'm going to do to analyze this is go down to the oscilloscope here, and we have our gamma ray signal that I showed you still coming in pretty strongly there. So I'm just going to disconnect it for a minute here from this connector, take it off. And so it comes out, so there's no more gamma ray signal. But what I'm going to do now is take this other shorter cable here and plug it into where the gamma ray signal was. And over here, I'm going to plug it into this port, this B and C connector on the oscilloscope. So it turns out what this is on the oscilloscope here is a wave generator. So the oscilloscope has sort of a built-in waveform generator just built into it. So sort of like 2-in-1. All the oscilloscope functionality is over here with the inputs and the channels, but then this knob over here sends an output like a waveform on the output right here. And if I sort of look at what we have, if I press this configuration button here, you can see that we have a variety of waveforms we can choose from here. It went away, so we can choose from like sine, square, ramp. And I'm going to leave it on pulse because the gamma rays are sort of coming in pulses, so I left it on pulse right there. So you can see I've got pulse selected. And then when I hit this blue button over here, this blue waveform button right here, the waveform is turned on. So see where there's two lines on the oscilloscope. But let me just adjust the trigger a little bit down like that. And now the times for division, maybe something like this. And so you can see now there is indeed a pulse coming out. And this is generated by the waveform generator in the oscilloscope itself. So we bought the oscilloscope. It looks like we bought 2 for 1 because there's a waveform generator built in. And if I go here on the oscilloscope and sort of adjust the amplitude right here, then this knob here that my hand's on becomes the amplitude adjust. So you can see now as I go, see the pulse getting larger and smaller. So in other words, I'm able to just produce a very carefully controlled pulse out of the oscilloscope that I'm just feeding into the oscilloscope itself. Okay, so doesn't seem very intelligent at the moment, but let me just show you what we can do with this. So I just wanted to convince you that the oscilloscope can indeed produce pulses like that. So let me take this cable off. We don't need it for the moment here. And what I'm going to do, though, is now I'm going to go back over here to the amplifier. Let me connect this back, the gamma ray. Remember, this is the key gamma ray signal coming in. I'll connect that back over here. And so the trigger level is all messed up, so we don't see the core gamma ray source, but I'm just going to pull this whole connector here right off of the output to the amplifier. Remember, this is sort of a famous sort of signal cable here that's split in 2 ways. This is coming out of the amplifier right here, and this cable goes to the oscilloscope, and this one goes to the data acquisition box, just a T in there that's splitting the signal. So I'm just going to take this, and I'm going to plug it directly into the waveform generator itself, okay, like that. And so instead of having the gamma ray amplifier as the output, I'm just going to use that wave generator as the output. So I can, again, I still see the pulse on the oscilloscope, but now I'm also piping it over to the data acquisition software on that other cable. And so again, I hope you understand what I'm doing here is that by turning this knob here, I can change the amplitude of the pulse. You can see it changing on the screen right there. And when it changes, that way I can send a variable voltage into the multi-channel analyzer to see exactly what it does. Okay. So what I'll do over here now is we'll look at the multi-channel analyzer like this. Okay, something like that. Let's get that focus going here. Come on. There we go. There's my focus. Okay. A little trouble finding the focus here. I'll have a focus on it, something like that. There we go. Okay, focus looks good now. Okay, so what I'm going to do now is I'm just going to start running these pulses into the multi-channel analyzer. So I'm going to go over here and hit the green traffic light to get it going. And let's see what we get. So we see, come on, focus. So we see the spike coming up there. See that? Just one channel. And I'm going to risk the focus again by doing this, but go back to the oscilloscope. One pulse amplitude. See that? Just this voltage right here is sort of stimulating the counts in just one channel of the MCA. Let me change the scale again to see where that thing tops out. There we go. So it just keeps growing and growing. And I'd like you to think of it now about why is that one channel growing and growing like that. Okay? And the reason is, of course, there's only one voltage going in. So the black box, I'm not going to move the camera anymore. Looks like the focus is kind of messing with me here. But the black box, the data acquisition box, always sees the same voltage and determines what channel that voltage should go in. Looks like it's around channel, I don't know, 400 or so. And just keeps seeing that voltage over and over again. So it says, I see it once, see it twice, see it 3 times, 4, 5, 6, to the tune of almost 5,000 times now. That pulse has been piped into the multi-channel analyzer almost 5,000 times. And so that's sort of the count that we're seeing on the screen there. I guess not quite 5,000, I guess it's up about 2,200 or something like that, okay? And so how could I sort of change this? How could I maybe stimulate a different channel? Well, by changing the voltage over here. So what I'm going to do, I'll risk that focus again. Let me go over here so you can see what I'm doing. I'm going to go back over here, and I'm going to turn that amplitude knob on the oscilloscope to make the pulse larger. Okay, so the pulse is a bit larger now. And when I do that, the pulse is a bit larger in voltage now. When I do that, I no longer see this original peak growing, but one right next to it is starting to grow. Okay, why is that? Well, the voltage is larger now. So see, the multi-channel analyzer is mapping the larger voltage into a slightly larger channel there. So this larger voltage has been seen now about 1,000 times, 0, 1, 2, 3, 4, up to about 1,100 times now, and off it goes. And the pulses are very, the channels or these peaks are very narrow, because plus or minus some sampling uncertainty, it's all more or less the same voltage, and so we just see these spikes in voltages coming up. So I'll just let you watch this now just for a minute. So what I'll do, I'll go back to the oscilloscope. I won't touch the camera, but I'm going to increase the amplitude even more. Okay, so the pulses. Well, I can't go any higher with this pulse here. But let me see if I can go lower then. So we'll just go lower. Not higher, sorry about that. Okay, go back to amplitude. And let's go lower. So we're going to go lower now. See what happens. So see if I go even lower in voltage. This is lower than the both I've chosen before. I can see that little spike right there, little peak right there growing. That corresponds to that voltage. And we sort of let that, maybe I'll let the other ones get off the screen so we see it grow a bit more or something like that. So that one voltage has been seen almost 368 times now as the MCA samples it. And if I turn the amplitude down even more, I can stimulate another channel. There we go, something like that right there, see? And so I hope you see then that this is what the MCA does. Let me just back up here so we can see everything. The input goes into the black box right here. Any voltage from 0 to 10. The MCA software looks at that voltage between 0 and 10 volts, determines what channel it should fall on, and just increases the count event in that channel so I can basically see how many times a given voltage was seen on the little black box. That's what the MCA does, and that's what multi-channel analyzer does. Here's the multi-channels, and the analysis is telling me how many times a given voltage was seen and throws that voltage into a count of a given channel. Multi-channel analyzer. So that's what it does, and I hope this experiment with the voltage here using the wave generator on the oscilloscope has helped you see that. I changed the voltage of this pulse here, and I'm seeing how that voltage gets mapped into what channel on the multi-channel analyzer. That's sort of what it does. And so you're left wondering then, what exactly would this voltage spectrum channel map look like if it was something like a cesium-137 source coming in? And so we'll leave it at that and pick this up in the next video by looking at some actual radioactive sources.